So here we have current I is equal to Q by T. This is Ohm's law, V is equal to IR. Factors affecting the resistance: as the length increases, resistance increases. As the area increases, resistance decreases. If you bring down in the one equation, it is R is equal to rho into L by A, and rho is equal to R into A by L. And here this is temperature dependence of resistance, and this is for resistivity. Drift velocity, there are three formulas. This is current density, and this is current density. What is the unit? Current density is ampere per meter square, and sigma is equal to conductivity, mho per meter, MHO, mho per meter, or Siemens per meter, or per ohm per meter. So this is the unit, note down. Next is mobility, magnitude of drift velocity per unit electric field, mu is equal to VD by E. So these are the units. Now resistance in series, resistance in parallel, energy stored in energy formula, it is measured in joules. Energy is measured in joules and power is measured in watts. Okay, watt. Okay, named after James Watt, and we have 1 kWh value. How much it is? 3.6 into 10 to the power of, is it 5 or 6? I think 6 joules, right? So that is also equal to 1 HP. Horsepower is equal to 746 watts. Okay, and we have V is equal to E minus IR, I is equal to E plus E by R plus capital R. Is that clear? So please note down these formulas. Then we will go with the next cells in series and cells in parallel. So cells in series, we are starting with cells in series. So here we are keeping two cells like this. This cells in series and parallel question came for 3 mark in one of the board exam. I think 19th board exam, 2019 March board exam. Again, every set has a different one. So E1 and E2. This is R1, R2. So what happened? This is A, this is B, and this is C. 3 points we have given. So internal resistance is R1, internal resistance is R2. What is internal resistance? Can anyone say the definition? What is internal resistance? Yes. Can anyone say what is internal resistance? Oh my God.
I don't know the exact definition.
Yeah, you can tell in your own words, not a problem.
The resistance experienced inside the capacitor apart from the overall resistance in the circuit.
That is the resistance offered by the electrolyte. Resistance offered by the electrolyte is known as internal resistance. Okay, what is EMF? Electromotive force. I have given 3 definitions. The first definition is what?
Potential
work done in moving a point from moving a charge from one point to another.
Yeah, work done in moving a charge from one point.
Potential difference before the circuit is open.
Yeah, good. Potential difference of the cell when the circuit is open. Third one, maximum potential difference in the circuit. These are the 3 definitions of electromotive force. Okay, we can write any one. So now this is equivalent to what? This is equivalent to E equivalent. Okay, I'm writing here E equivalent, and this is R equivalent. Okay, E equivalent and R equivalent. This is what? A, and this is C. Okay, A and C. Now here we have E1, E2. E1, E2 are what? EMF of the cells. EMF of cells. And R1 and R1, R2 is equal to what? Internal resistance. R1, R2 is said to be the internal resistance. Clear? Now V of A, comma, V of B, comma, V of C. Okay. They are the potentials at potentials. They are potentials at A, B, and C. These are the 3 potentials at A, B, C. Now V of A minus V of B. What is this? This is said to be the potential difference between positive and negative terminal. Potential difference of positive and negative. When we speak about one plate, it is potential. When we speak about difference, then that is potential difference. So this point is a potential. B is potential, C is potential. But when we speak about the difference, A and B together, then that is said to be the potential difference. So potential difference of positive and negative terminal. Okay, what is that now? So V of VAB is equal to what? V of A minus V of B. Okay, that is equal to what? E1 minus IR1 for the first set. We know the formula, right? I wrote just all the formulas. V is equal to E minus IR. Okay, this is the formula. Now, now here, next is what? VAB. What is that? VBC. VBC is equal to what? V of B minus V of C, which is equal to what? E2 minus IR2. Okay, next this is equation number 1 and this is equation number 2. Next is what? Suppose if I'm writing VAC. VAC is equal to what? VA minus VC. Okay. So that is equal to what? V of A minus V of B, then plus V of B. I'm adding and subtracting the same. Okay. Adding and subtracting V of B. Then what will happen now? So here it is VAC is equal to what? VAC is equal to V of A minus V of B. Okay, V of A minus V of B minus again V of B minus V of C. Okay. Here V of B minus V of C. This is the value. Okay, these are the two. But what is V of A minus V of B? What is that? E1 minus
E1 minus R1.
IR. What about the second one? E2 minus IR. So put it together now. E1 plus E2 is equal to minus I into R1 plus R2. Okay. So this is VAC. Clear? That is VAC. Now, what we are writing that is equal to what? This is equal to E equivalent. This is minus I into R equivalent. So R equivalent. So what is E equivalent? That is what? E1 plus E2. And R equivalent is equal to what? R1 plus R2. Okay. So these are the EMFs and resistances. This is for the series. Okay. This is for the series. So suppose if two negatives are connected together. Example, if two negatives or two positives are connected together. Negatives are connected. If two negatives are connected. Example like this. I mean in this way. Like this. If they are connected in this way. Suppose this is E1 and this is E2. Then what is E equivalent? It is equal to E1 minus E2. Clear? Whichever is bigger, you have to write first. Is that clear? Where E1 is greater than E2. The same thing happens like this also. If you are connecting in this way also. In this way also. If this is E1 and this is E2, we write in that way. Clear? Whichever is bigger. So you should be very careful when you see such signs. Generally, the normal way is connecting like this, negative to positive, negative to positive. Is it clear, all of you? Is it
Yes,
clear?
sir.
Okay.